So I just wanted to show you another example. We're doing number 3, which is we're going to solve it both with systems of equation and using the addition method and Cramer's rule. I already wrote everything out. Hopefully that doesn't confuse you. I'll try to go step by step with it, but this is the one we're doing right now. So we kind of start right here. 3x plus 4 equals 6, 2x minus 6y equals 5, and what we need to do is reduce one of these variables, either x or y. This one's not as simple. I can't just multiply one equation by, another variable like we had done before to reduce it out. Another coefficient to the variable to reduce it out, because I don't have, as we did before. So what I need to do is I need to find some commonality between the two. So what I chose is I'm going to use these 4 and this 6. I'm going to make these guys 12 because those are pretty common. So to do that, I need to multiply the top equation by 3 and the bottom equation by 2. So I kind of just distribute this out. And what I get is 9x plus 12y equals 18 and 4x minus 12y equals 10. You can kind of see just distributing those out. I get this. So I'm going to go ahead and add those two together. As we can see, the 12s will now cancel out. So I have 13x and no y equals 28. So now I have 13x equals 28. I need to divide out the 13. I get x equals 28 over 13. Again, another ugly fraction that I don't want to work with. But what we have to do is plug this guy back into our original equation over here. So 3x plus 4y equals 6 is what we're going to use. So now I know what x is, so I know what this variable is. So I have 3 times 28 over 13 plus 4y equals 6. Just got to do some muscle math with a calculator now. So it's just 84 over 13, because I did 3 times 28, plus 4y equals 6. Come over here, I just rearranged this. I have 4y equals 6 minus 84 13. All I did was subtract the 84 13ths to the other side. I just did this in a calculator. 6 minus 84 13ths is equal to minus 6 13ths. And then I just divided that in a calculator, and I got minus 3 over 26. So using addition, these are my solutions to the equation, both x and y. Cramer's rule, a lot easier. Basically, all I'm going to do is set up my matrices. So I have a 2 by 2 matrix, and then I have the answer matrix over here. And I had originally 3, 4, 6, 2, minus 6, and 5. So I set that up as 3, 4, 2, minus 6, and my answer matrix of 6 and 5. We're going to solve for the D matrix first, so I set that guy up as 3, 2, 4, minus 6. Just cross multiply 3 times negative 6 minus 2 times 4. Simply just get minus 26. So D is equal to minus 26. Let's solve the D sub x matrix. To do that, I replace my x values with my answer matrix. So I have 6 over 5, 4 minus 6. Cross multiply again. 6 times negative 6 minus 5 times 4. 36 minus 20. I get D sub x is equal to minus 56. I just want x, so how do I get x? I just divide out. That means D sub x over D is equal to x, which is minus 56 over minus 26, because my D is minus 26 and my D sub x is minus 56. We reduce this fraction down. It's minus 28 over 13. Same thing over here. Now to find my D sub y, I have my y value. So I have to substitute in the answer matrix for that. So I have 3, 2, 6, 5, cross multiply. 3 times 5 minus 2 times 6. 15 minus 12 is 3. D sub y equals 3. Y is equal to D sub y over D. Again, my D sub y is 3. My D is minus 26. So this is just 3 minus 26. Again, 28, 13, 3 minus 26. 28, 13 minus 3, 26. Minus 26. Same answer. Much easier way to do it with Cramer's rule.